Welcome to the IrisLogic YouTube channel. In this video, we'll explore the world of Kubernetes, a game-changer in modern software development and deployment. Kubernetes is the Swiss Army knife of container orchestration, allowing you to efficiently manage and deploy applications. Whether you're a developer, a DevOps engineer, or just curious about this powerful technology, you're in the right place. But why is Kubernetes so important? In the world of software development, it's become a cornerstone for building scalable, resilient, and efficient applications. So, get ready to unlock the full potential of Kubernetes with IrisLogic. Let's dive in. Kubernetes, often abbreviated as Kubernetes, is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It plays a pivotal role in the containerization ecosystem, allowing organizations to streamline the management of containerized applications across various environments, from development to production. Kubernetes is crucial because it abstracts away the complexities of infrastructure management, offering a unified framework for deploying and scaling applications. It not only simplifies the orchestration of containers but also enhances their reliability, scalability, and portability. Core components of Kubernetes. Pods are the smallest deployable units in Kubernetes. They are a logical grouping of one or more containers that share the same network namespace and storage volume. Pods are the basic building blocks for deploying and scaling applications. Nodes are the physical or virtual machines in a Kubernetes cluster where containers run. They are responsible for executing the containers and providing resources, such as CPU and memory, to the workloads. A Kubernetes cluster is a set of nodes grouped together to form a single unit. Clusters consist of a control plane and multiple worker nodes. The control plane manages the overall cluster state, while worker nodes run the containers. Setting up Kubernetes. 1. Setting up a Kubernetes cluster. For local development, Minikube is a popular tool. It creates a single-node Kubernetes cluster on your local machine. Install Minikube, start the cluster, and you're ready to experiment with Kubernetes locally. Alternatively, managed Kubernetes services like Google Kubernetes Engine, GK, Azure Kubernetes Service, AKS, or Amazon Elastic Kubernetes Service, EKS, provide scalable, production-ready clusters. These services abstract much of the cluster management, making it easier to set up and operate Kubernetes at scale. Installing and configuring kubecontrol. Download and install kubecontrol, the Kubernetes command line tool, suitable for your operating system. For example, on Linux, you might use package managers like apt or yum. On macOS, tools like Homebrew are common. Windows users can utilize Chocolatey or download the binary directly. After installation, configure kubecontrol to connect to your Kubernetes cluster. This involves setting up the kubeconfig file, which contains cluster information, authentication details, and context settings. Kubernetes networking concepts. Services are an abstraction layer that enables communication between different parts of an application or between applications within a Kubernetes cluster. They provide a stable endpoint like IP address and port to access a set of pods, regardless of pod rescheduling or changes. Ingress is a Kubernetes resource that manages external access to services within the cluster. It acts as a 7 application layers HTTP or HTTPS router, allowing you to route traffic to different services based on rules, perform SSL termination, and more. Network policies are a Kubernetes resource that allows fine-grained control over network traffic within the cluster. They define rules for how pods can communicate with each other and which pods can access specific services. Kubernetes supports different service types like cluster IP, node port, load balancer. Use kubecontrol exposed to create a service for a deployed application, specifying the type and ports. Kubernetes services inherently provide load balancing across pods. When multiple pods exist behind a service, traffic is distributed among them based on the service's defined access method. Services act as a DNS entry within the Kubernetes cluster, allowing other pods to discover and connect to them using their service names. DNS resolution within the cluster routes traffic to the appropriate service endpoints. Managing data in Kubernetes importance. Efficient management ensures security, scalability, and agility in deployments. Config maps and secrets are pivotal tools in Kubernetes for managing data. Config maps act as repositories for non-sensitive configuration data stored in key value pairs, utilized either as environment variables or volumes within pods. On the other hand, secrets are tailored for sensitive information, offering secure access to pods, employed similarly to config maps as environment variables or mounted volumes. Both config maps and secrets play essential roles in application configuration, with config maps handling non-confidential settings and secrets ensuring the secure management of sensitive data within Kubernetes environments. In a CI or CD pipeline, Kubernetes serves as the backbone for deploying and managing containerized applications seamlessly. It integrates effortlessly with popular CI or CD tools like Jenkins, GitLab, and Tekton. These integrations allow for automated workflows, leveraging Kubernetes capabilities to scale, orchestrate, and maintain applications across diverse environments. Through these tools, developers can define deployment pipelines, triggering automated deployment processes upon code changes or updates. Kubernetes, as the orchestrator, ensures consistent, scalable deployments, while CI or CD tools handle workflow automation, utilizing Kubernetes functionalities to achieve efficient, automated deployments from development through production environments. Kubernetes has become indispensable for modern enterprises and is swiftly establishing itself as the gold standard for orchestrating large-scale applications and solving complex challenges in real time. If you're seeking to harness the power of Kubernetes, our team at IrisLogic is your dedicated partner. From seamlessly orchestrating applications to efficient resource allocation, we are committed to optimizing your Kubernetes journey. Whether it's setting up cloud-native infrastructure, managing data pipelines, or executing models, we're your trusted allies in enhancing scalability and reliability while maximizing resource utilization. From cloud hosting and data ingestion to model execution, we're your partners in improving data visualization and implementing machine learning models to meet your business needs. We've collaborated with top-tier companies and startups to devise and execute big data strategies that have transformed their business outcomes. Reach out to us today and embark on your journey towards scalable, resilient, and agile application deployment with Kubernetes.